Hello, GED students! If you felt a little lost by this, don't feel bad. Haven't taught you anything just like this before, but I do want to show you how it totally can be tackled using a skill we already know. So let's take a look. It says, which expression is equivalent to 5y squared minus 19y minus 4? Okay, so there's like this algebraic expression involving some different terms. A y squared term, a negative 19y, and a negative 4. Now, it's an interesting question because it just says which expression is equivalent to. It's just asking what's equal to this. And you know, we can play with numbers quite a bit to find things that are equal to other things. So where do I even go from here? Well, the clue is in the answers. Take a look at the form of all of these answers. Every one of them is in the form of some grouping. So in this case, 5y minus 1, shoved up against another grouping, like y plus 4, with nothing between them. So basically, two groups of things multiplying. So no, you might not know how to tackle this thing right here, but we do know how to do the multiplication there. That's one way we know how to play with these numbers. Let's do it. Let's multiply each one of these out and see if we can force it or get it to be equivalent to look like that. So we'll start with the first example. 5y minus 1, or the quantity of 5y minus 1, I should say, times the quantity of y plus 4. I'm just saying the quantity because it's a whole group times a whole group. So remember, when multiplying groupings, you have to take every term in the first grouping and multiply it out to every term in the second grouping. So let's start with 5y times y. Well, there's only one number. That coefficient out front is 5. But be careful, y times y. When you have repeated factors, even unknown ones, you can use exponents to represent that. So y times y is y squared. So 5y times y is 5y squared. And then 5y times positive 4. Well, 5 times positive 4 is positive 20. But it wasn't just 5, it was 5y. So I'll have positive 20y. Wonderful. Now I passed out 5y. It's time to pass out negative 1. When I multiply, I think of that as a negative. So what's negative 1 times y? It's just negative y, or negative 1y. Doesn't matter which way you write it. I think I will write it as negative 1y right now because it's going to help me in the next step. But I could just as easily write it as negative y. That's what I usually do. And negative 1 times positive 4 is negative 4. Now, I did my multiplication, but remember, just like when we did multi-digit multiplication back in elementary school, if we have pieces and parts that can add and subtract together at the end, we should do that. And we do. We have two y terms. Some number of y's, some other number of y's. Those are like terms, we can combine them. So if I have positive 20y and I take away one of those y's, I'll have positive 19y. Now I've got nothing to combine with the y squared term, so I still have 5y squared, and I have nothing to combine with the minus 4, so I still have minus 4. So this expression here looks pretty tempting because it's very similar to the one above. I have a 5y squared. I have a 5y squared. I have a negative 4 or a minus 4. There's a negative 4 or a minus 4. But watch your signs. This one has plus 19y, and the one we were looking for was minus 19y. And so that one is not going to work. But I got to tell you, with the signs, with it just being a sign error, I kind of want to try one with the same numbers but different signs. Let's see. So 5y minus 1. Oh, let's try this one. See, instead of being 5y minus 1, I have 5y plus 1. And instead of it being y plus 4, I have y minus 4. So I think A didn't work, no, but let's try multiplying out C. And you might say, Kate, I didn't notice that. That's okay. You could do them one by one. You know, you don't have to jump around. It's just that I'm so lazy. If I have a guess, of what might be the right answer. I want to try that first. So let's try C. I always tell my students, guessing and checking is a legitimate math strategy, but don't forget the checking part, you guys. Don't just guess and move on. Check your guesses. Okay, so let's try 5y plus 1 times y minus 4. So once again, we can multiply groupings if we pass out every term. So let's do 5y, the first term in the first grouping, times y, the first term in the next grouping. So 5y times y is 5y squared. And now we'll pass it out to the next term in the second grouping. So 5y times negative 4 is negative 20y. I'm done passing out 5y, but I need to do the positive one. So positive 1 times y is, yes, just positive y, or positive 1y. They mean the same thing. And positive 1 times negative 4 is negative 4. Great. Once again, I see some like terms here. I have some number of y and some other number of y. Now be careful. Don't ignore the negative sign and say 20y plus 1y is 21y. You have to keep the number sign with it. So this is negative 20y plus 1y. It's like you owe somebody 20 y's, but then you give them a y. Now feel free to do it in your calculator. Negative 20 plus 1. But you're going to find that you get negative 19y. And now, of course, there isn't anything to combine with the minus 4 and nothing to compare with the 5y squared. And now I can see that I have found an equivalent expression because if I played around with it, moved it, in this case, simplified it, it comes out to the same thing, 5y squared, negative 19y, negative 19y. Negative 4. Of course, though, if you had not been careful with your signs, you totally would have missed that. So make sure that if you struggle with positive and negative numbers, you're doing that work in your calculator. Awesome. And if you tried multiplying these others out, you would not get the same expression. All right, correct answer is C. And by the way, I am prepping you, whether you realized it or not, for a type of problem that I haven't taught my beginners that does come up on the GED, where you're asked to factor something that looks just like this. And so you can put this in your notes if you're still with me. But factoring is the opposite of multiplying. It's like pulling a multiplication answer back out into its original multiplication problem. And so exactly the way we dealt with this problem by multiplying the answers back out, we could do it with any of the examples where they ask us to factor. All right, you guys, very nice job. Super proud of you. Happy learning.